Imagine you're looking up at the night sky, admiring the serene beauty of the stars and planets gently lighting up the vast cosmos. Now, imagine that peaceful scene interrupted by an asteroid, silently making its journey through space at incredible speeds, headed toward our planet. Sounds dramatic, doesn't it? Yet the reality of asteroid impacts is not just Hollywood fiction, it's science fact. Asteroids have impacted Earth countless times throughout its 4.5 billion-year history. Some of these impacts have profoundly shaped the course of life, altering ecosystems and even leading to mass extinctions. Think about the dinosaurs, once dominant on our planet, yet their reign ended abruptly around 66 million years ago due to a catastrophic asteroid impact in the region of modern-day Mexico. That asteroid, measuring roughly 10 kilometers wide, released energy billions of times greater than our most powerful nuclear weapons, drastically changing Earth's climate and environment. But let's pause for a moment. Should we be worried? How likely is such a catastrophic event to happen again in our lifetime? The good news is, large-scale extinction-level impacts are incredibly rare. The odds of an asteroid similar to the dinosaur killer striking Earth again soon are astronomically low. However, smaller asteroids, ranging from a few meters to several hundred meters, do pose a real, albeit much smaller risk. The famous Tunguska event in Siberia in 1908 flattened about 2,000 square kilometers of forest due to an asteroid roughly 50 meters wide exploding in the atmosphere. Then, more recently, in 2013, a much smaller asteroid exploded over Chelyabinsk, Russia, shattering windows, damaging buildings, and injuring over 1,000 people. Given these examples, it's clear we must take asteroid impacts seriously. So, how exactly do we prepare? First, we detect them. Early detection is crucial, and astronomers worldwide have been scanning the skies for decades, identifying and tracking near-Earth objects, NEOs. Programs like NASA's Near-Earth Object Observations Program and ESA's Planetary Defense Coordination Office continually monitor space, cataloging thousands of asteroids, plotting their orbits, and assessing potential threats. Once we spot an asteroid with a concerning trajectory, our next step is determining the risk level. Scientists calculate its orbit precisely, predicting its path years, even decades into the future. Advanced computer simulations allow us to foresee potential collisions well in advance, providing ample time to react. But let's say we discover an asteroid heading directly for Earth. What happens next? Is there anything humanity can realistically do? Surprisingly, yes. Numerous strategies are being developed and tested to deflect or disrupt a dangerous asteroid. One of the most promising methods recently tested successfully is kinetic impact, essentially hitting the asteroid with a spacecraft to alter its trajectory. In fact, NASA's DART mission, Double Asteroid Redirection Test, successfully demonstrated this technology in 2022 by crashing a spacecraft into Dimorphos, a small asteroid orbiting another larger asteroid named Didymos, effectively changing its orbit. Another intriguing method is the gravitational tractor approach, using a spacecraft's gravitational pull to gently nudge an asteroid off course. It's slow and subtle, but potentially very effective for smaller objects, especially if detected decades in advance. Alternatively, some experts consider nuclear deflection, detonating a nuclear device near the asteroid, to be a viable, albeit controversial, option for larger threats. This method would ideally vaporize the asteroid's surface and push it onto a safer trajectory without destroying it completely, thus avoiding multiple hazardous fragments. Beyond technology, international cooperation is essential. Asteroids don't recognize national borders. This is a global issue. Agencies around the world, including NASA, ESA, JAXA, Roscosmos, and China's CNSA, are already collaborating to develop unified responses and share crucial data. Regular simulations and international exercises help ensure that governments and scientists globally are ready to act swiftly and effectively in an actual event. What about us, individuals on Earth? How should we prepare? Public education and awareness are vital. Understanding the reality of asteroid threats, however unlikely, helps us avoid panic and misinformation if an event occurs. Cities and regions can prepare disaster response plans similar to earthquake or hurricane preparedness, ensuring communities can respond efficiently and safely. So returning to our initial question, how do we prepare for an asteroid impact? The answer is multifaceted. We invest in science and technology, detect and monitor asteroids diligently, develop practical deflection methods, foster international cooperation, and prepare our communities through education and emergency planning. Ultimately, asteroid defense represents humanity at its most proactive and collaborative. It's an inspiring example of how, when faced with cosmic threats, we come together, look skyward with vigilance and ingenuity, and safeguard our collective future. Next time you gaze upward, take a moment not only to appreciate the beauty of the cosmos, but also the quiet, diligent work of scientists around the world, working tirelessly to ensure that our place beneath the stars remains safe, secure, and vibrant with life. Because after all, preparedness today secures our tomorrow.